What is steady-state heat conduction? Imagine holding a metal rod with one end heated and the other cooled. Over time, the temperature along the rod stops changing, even though heat keeps flowing. That's what steady-state heat conduction is all about. It happens when the temperature at every point in a material stays the same over time, despite continuous heat transfer. In this state, the heat entering any part of the material equals the heat leaving it. So the temperature profile remains constant. Think of a wall between two rooms at different temperatures. After a while, the temperature inside the wall stops changing. The heat flows steadily from the warm side to the cool side, but the temperature at each point in the wall stays the same. This is steady-state conduction. It's like a constant flow of heat with no buildup or loss inside the material. In steady-state heat conduction, the temperature change across the material is called the temperature gradient. This gradient stays the same over time but can vary in space. The rate of heat transfer through the material also remains constant. This means the same amount of heat moves through every part of the material each second. Because of this, the internal energy inside the material stays steady. Mathematically, steady-state conduction is often described using Fourier's law of heat conduction. This law states that the heat flux, or the amount of heat passing through a surface per second, is proportional to the temperature gradient. The proportionality constant is called the thermal conductivity, which depends on the material. For example, metals like copper have high thermal conductivity, so they transfer heat quickly. Steady-state conduction can happen in simple shapes like flat walls or pipes, but it also occurs in more complex objects like cylinders or spheres. Engineers use this concept to design insulation for buildings, cooling systems for electronics, and many other applications. They often model these systems as a network of thermal resistances, similar to electrical resistances, where the temperature difference drives the heat flow. Understanding steady-state heat conduction helps us predict how heat moves in everyday situations where temperatures stay constant over time. It's essential for creating energy-efficient buildings, managing heat in electronic devices, and developing thermal insulation. By knowing how heat flows steadily through materials, engineers can make smarter choices to control temperature and save energy.